Alright, so we're ready for section 9.2, naming and writing formulas for ionic compounds. So here's our objectives. This is what we're trying to get out of this. Be able to apply the rules for naming, writing formulas for ones that are binary ionic compounds and for polyatomic ions. Alright, so let's start with binary ionic compounds. And originally, a long time ago, if you came up with a compound, if you discovered it, you got to name it. And that was fine when there weren't that many compounds, but as that number of compounds grew, that got to be kind of a pain to try to memorize the name of everything. So a French chemist named Antoine Lavoisier came up with a system to name compounds. And that's what we use today. So if we talk about a binary compound, binary simply means that it has two elements. Now we can have binary ionic, binary molecular. We're going to talk about the ionic ones here. And if we have anything that's binary, what we do is we simply take the cation name first, and then we put the anion name. So we just write those two down. We've talked about naming those ions, and that's all we do. So for instance, let's say that we have CS2O. So if we go to the board, we know that CS is cesium. So we have cesium. And if we know that O stands for oxygen, but as an ion we call it oxide, so we would call it cesium oxide. Okay, let's take a look at the next one. If we talk about CuO, we know that the first one is copper, but there's kind of a little reminder here. It says it's a transition metal, and when we have transition metals, we need to put Roman numerals in. So we need to decide what the charge would be, or as they call it, what's the oxidation number on this. So if we look at the compound, we see that it's CuO. We know that oxygen has a 2- charge, and since compounds have to be neutral, we know that the copper must have a 2+ charge. So this is copper 2. So we put the Roman numerals in, copper 2 oxide. And the next one, we have tin, or SnF2. Tin is Sn. And once again, it's a transition metal, so we need to kind of figure out what its Roman numeral is going to be. And in this one, F, each F is minus, but there's two of them, so we'd have to take that times 2, so therefore we have a -2. So the tin, to balance that out, must be +2. So this is tin 2 fluoride. Not flour. We don't want flour. Here's my eraser here. Get rid of that. Fluoride. Okay. Now on the next one, sulfur. Sulfur's -2, and there's two of those. So -2 times 2 gives me -4. Therefore, in order to balance that one out, this has to be +4. So this is tin 4. Sulfide. Remember that the anions, we change the names to end in IDE. Alright, so let's do this the other way around. If we want to write the formulas, we simply write the symbol for the cation, then the symbol for the anion, and we put the necessary subscripts in to make sure it balances. So let's take a look. If we have potassium chloride, we know that potassium, we can look it up, that's K. And we have chloride, and that's Cl. And what we need to do is figure out what's the charge on each of these. Well, potassium is in group 1, so it's a +1. Chloride is in group 7, so it's a -1. So you can see those two things are going to be balanced. There's one positive, one negative. So the formula is going to be KCl. Calcium bromide. calcium bromide, we've got calcium, calcium is a 2 plus, bromide, which is bromine, is Br minus. Now the easy way to figure out what the subscripts are for each of these is if you take this number here, you can kind of just cross it down there, and there's no number there, that's a 1 really, and we can cross it down there. So what we would get is Ca1, which we don't write, Br2. So there's my formula, calcium bromide. Okay, iron 3 oxide. The nice thing about the Roman numerals, it tells me exactly what the charge is. So it's iron 3 plus. Oxide stands for oxygen, so that's O, and oxygen's a group 6, so it's 2 minus. And just crisscross them, and you should get Fe2O3. Okay, not too bad. Alright, now here's calcium sulfide, and this one is a little bit different. We go calcium 2 plus. Sulfide is sulfur, and that's in group 6, so that's a 2 minus. Whoops, let's get that looking right. 2 minus. And if you say, hey, let's crisscross them, you would get Ca2S2, but remember, with ionic compounds, we always want the lowest whole number ratios. We're not, we're always talking about those simplest, easiest ratios. Well, the easiest ratio is 1 to 1 because the 2 plus cancels the 2 minus. So the correct formula is CaS for this one. Alright, copper 2 sulfide, we got Cu2 plus, and we've got sulfur 2 minus. Same kind of thing. Simply going to be CuS. And let's do one more here. Let's do potassium nitride. Potassium is K, and we know that K is in group 1A, so it's a +1. Nitride, N, it's a 3 minus, it's group 5, so it'd be 3 minus. And we can just crisscross these, and so we're going to get K3N. Alright, so here's some more. I would like you to do 10 and 11 and put those in your notes, and we'll talk about them in class. Alright, so let's talk about ones that have polyatomic ions now. It's a little more challenging, but not too bad. If we have a polyatomic ion, if we have one like calcium nitrate, what we do is simply take those same things, do the same thing we did. We got calcium, find the charge on that. Well, it's in group 2, so it's a 2 plus. We look up nitrate on our chart. So in the chart, you're going to see that nitrate is NO3 minus. Now we're going to crisscross those again. So we're going to take the 2 down here and the 1 over here. So we're going to get Ca. But in order to indicate that we have 2 nitrates, we need to put that in parentheses because we want the entire thing. We don't want it's not just the O3 times 2, it's the NO3 times 2. So we go NO3 and in parentheses 2. So it's Ca parentheses NO3 parentheses 2. And this indicates, this is just like algebra. It indicates this entire thing. So the oxygens and the nitrogens are all multiplied by 2. So really in here there's 2 nitrogens and 6 oxygens. So just think of it very, very similar to the distributive property in algebra. That's what we're doing here in reality. Okay, so let's try strontium sulfate, and I have strontium Sr 2 plus, sulfate SO4 2 minus. So you've got to look those up. If you don't know them, you got to look them up in the chart. And you can see now this is where you've got the 2 and the 2. We don't want to crisscross those. We just want to keep those things at 1 to 1 now when it's a 2 and a 2. So this is just going to be SrSO4. All right, let's do lithium carbonate. Lithium is Li plus. Carbonate, CO3 2 minus. So we can crisscross those. The 2 is going to come down to the lithium. The 1 is going to go to the carbonate. So we're going to get Li2 CO3. We don't need to put parentheses around the CO3 if we only have 1. All right, magnesium hydroxide. Now here's one that you need to be aware of. Hydroxide is one of those polyatomic ions that doesn't end in ate or ite. So just be aware of it. It's an important one. It's one we use a lot, so you need to keep it in mind. Hydroxide, that's the OH minus ion. OH, a very good looking H there. OH minus, and then we have magnesium, which is the 2 plus, is a 2 plus ion. So we'll crisscross those. And we'll write it like this, Mg parentheses OH2. Now a lot of people, like I said, the parentheses are the key, the thing that people forget the most. But look at the difference here. If I write it like this, okay, that second one says I have 1 magnesium, 1 oxygen, and 2 hydrogens. Whereas the first one says I have 1 magnesium, I've got 2 hydroxides, so therefore I've got 2 oxygens and 2 hydrogens. So we don't want to write it like that. All right, and our last one here, potassium sulfate. Potassium is K+. If we look up sulfate, we find that that's SO4 2 minus. Crisscross those, we get the K2SO4. All right, so how do we name them if they have polyatomic ions? Well, state the cation, whatever the cation is first, and then the anion, just like we did before, the anion now being a polyatomic ion, and just name it that way. Okay, so we have lithium, well, LiCN, and once again, we're going to look at that first part, and we're going to write down the name of that. That's just a metal, so it's just going to be lithium. The cation's name stays the same. Then we look at the last part and we see that there's 2, so it's a polyatomic ion. We look it up in the chart and we find that that Cn stands for cyanide. Okay. If we do the next one, we've got NaClO, which is bleach, and we look up Na and we find that that's sodium. We know that. And then we look this up on the chart, ClO, and that is hypochlorite. And that's all you do. Write down the positive ion, write down the polyatomic ion, and that's how you name them. Now the next one, this one has the only positive polyatomic ion that we'll use. There are a couple others, but this is the only one that we really need to know. And so you can see now we've got 4 elements in here. Well, if we have 4, there must be 2 polyatomic ions, or something else that's a little bit different, maybe one with hydrogen in it. But here we do have 2 polyatomic ions, so we'd say we look up the NH4, we find that that is ammonium. So you just write it, ammonium. We look up the C2O4 and we find that that is oxalate. Oxalate. And just write that down. So there you have it. So ammonium oxalate. Alright, so what I would like you to do is write down the formulas of these compounds. So you might want to stop the video. I want you to do these 5, and then I've got another set, and I want you to have those done for tomorrow along with the problems that you did prior. So have those, and we'll talk about those in class. Also do these. All right.